Good morning, folks. Welcome to my session. Welcome to, I think, the first virtual DDD event as well. I'm really excited to be taking part in this. So before we start, a couple of bits of housekeeping. Please take a moment to look at the code of conduct. This is really important in all events, and I would urge you to take a closer look at the full code of conduct. And also, if you have any issues relating to the code of conduct, please use that link in the corner there to find out more and report. So this session, we are fundraising for the National Museum of Computing. So if you want to take part in that, head over to the Just Giving page and you can donate there. Also want to take a moment just to thank all the sponsors. I know we're virtual this year and obviously the costs are not the same as in-person events, but the sponsors have been very generous in terms of helping us with the infrastructure. Black Marble folks have done an amazing job getting this put together in such short amount of time. So huge kudos to them. And some of the other sponsors you can see there who have contributed to the Museum of Computing as well. So I want to say a huge thank you to them as well. And finally, if you want to follow along, let's make it social. You can tweet at #DDD2020 and you can follow the @DeveloperDay Twitter handle as well to see what other sessions are going on. So today I want to talk to you about essentially provisioning cloud infrastructure using software. And in particular, we're going to talk about .NET. So in terms of the agenda, what we're going to cover today is we'll talk about some popular approaches for provisioning cloud infrastructure. And I want to talk about some of the limitations of those approaches. And then finally, I want to really talk about a tool called Pulumi. Now, there's another session on Pulumi later on in the day in this track. So there may be some overlap in the two sessions, but you may want to take a look at that one as well if you're really interested in this topic, because you'll get a diverse point of view. Some caveats. So I'm going to focus on Azure and .NET in this session, but everything I'll talk about really is applicable to all cloud providers and also not just .NET. So this talk is inspired by my experience as a kind of a consultant dealing with cloud infrastructure with smaller teams and some of the challenges that we run into when we're trying to manage the infrastructure for them and helping them manage their own infrastructure. I just want to quickly mention that I don't work for Pulumi, so I'm talking a lot about Pulumi, but it's not a sales pitch. This is really the stuff I've learned having used it with my clients. Very briefly, who am I? So I'm Shahid Iqbal. I'm a freelance Azure consultant working kind of Azure, Kubernetes and other cloud native technologies. I'm a developer, I have been for about 10 years, but I think I'll probably just caveat by saying I haven't done a huge amount of coding recently. So when you see my code examples later, maybe I'm just setting things up for you. I'm also Microsoft Azure MVP, and I co-organize a meetup in the UK, MiltonKeynes.net. Main reason for this slide really is contact details. So we have a Q&A session available. So if you want to ask questions, please pop them in the Q&A. I'll be keeping an eye on that as we go along today, and I'll try and answer the questions as they come in. But if you don't get a chance to ask your question, then feel free to reach out to me on LinkedIn, on email, and my Twitter handle is on the top of the page as well. So when we think about provisioning infrastructure, the first port of call usually in this is portals. And portals are a great way to get started because each cloud provider has their own portal. I know there can be a bit of a love-hate relationship with portals, but generally speaking, portals give you a way of getting started provisioning your cloud resources. So key things that portals give you is discoverability. You can find out what resources are available for you to provision. They make things available, they give you information about them, give you documentation, give you examples. So they're really handy for that. They give you wizards to provision the resources. So these wizards allow you to, or guided setups or whatever you want to call them, they allow you to provision your resources and they hold your hand as they go through the steps, and they give you options and they ensure that you can't pick invalid options when you're provisioning these things. The other thing worth mentioning is that some people are just more comfortable with GUIs. I think there's a tendency in our industry to be a bit elitist and say we're command line junkies and we do everything from the command line. Now, I do want to call out that there's nothing wrong in using GUIs if you want. There are some challenges with the portal though. It's not easy to be consistent, certainly, repeatably. If you're anything like me, I'm terrible when it comes to consistency when I'm doing things manually. ensuring that you name things exactly the same or you use the same options every time can be a bit of a challenge. Some of the options can be buried deep in submenus. So in order to find an option, you need to know that you've got to click on the 3 dots here and then open the submenu and then go to the second submenu to find an option you may want. The key one really is provisioning lots of resources can take a huge amount of time because there's only one human doing the work. You can't really run things in parallel. And to some extent, you have to figure out dependencies between your resources. So if you're provisioning maybe an application and a database, you may need to provision the database first so you can get the connection strings and details of that before you provision the application in order to supply the connection strings. Because of some of these challenges, this is where this kind of infrastructure as code movements come along. So I'm not going to read the kind of quote out, but essentially what the quote says is it's a way of managing infrastructure, if you like, by using machine readable definition files rather than kind of interactive tools. Each of the cloud providers has their own solution to this. So with Azure, we have the resource manager. With AWS, we have CloudFormation, and Google has the deployment manager. What all of these providers do are essentially give you a markup language of some kind that you can use to define your resources. So what we'll do is we'll take a look at an Azure example. So this is a template for provisioning a storage account. Now, don't worry about the size of the text. We'll dive into specifics in a second. Just wanted to take a second to look at the amount of text on the screen and some of the weird colors and syntax, and we'll see that a little bit more in a second. So let's dive in a bit closer. So first of all, what we're doing here is we're defining some parameters, and we've got a default value specified. And then we've got some allowed values. So what we're doing in this template is we're ensuring that the people who use our template can have a default value picked for them, and they can only select certain values from a list. And this is great for consumers of our template, but as the writers of the template, we need to know what those valid options are. We need to have discover that. Here's the first kind of place where we start seeing some weird stuff. So we've got a location specified. Excuse me. We've got a location specified here. And if we look at the default value, we're doing some kind of function here. We're looking at resource group and we're getting its location. And this is the first hint that all is not well in the world of markup. Let's move on a bit. So now we are looking at variables. So variables are a way of essentially creating a value that may be either hard-coded or uses multiple other sources to create the value. And now what we're seeing here is some kind of concatenation function, which is taking the string store and then using some other string. And the specifics don't matter too much here. What I just want to highlight is that we are starting to see things which are not really standard JSON. What we started off seeing was what looked like JSON. Now things are not looking quite like normal JSON. Now we get onto provisioning the resources. And really what we're seeing here is we're starting to use some of those things we defined earlier. So now we're using the variable storage account name as the name of the resource. And we're pulling the parameters in for the location and the SKU name. So the takeaway here on these slides is really just looking at the syntax and saying, well, I need to understand what variables is doing. I need to make sure I know that the syntax is exactly like this. On this example, you can also output the variable. So sometimes you need the result of a provision to maybe pass into another system, for example. And here we can output the storage account name as an output. Once we have this template, we can then just run AZ group deployment create a resource group and then pass in that template. And this will get the Azure Resource Manager to provision those resources for us. We can do this with PowerShell as well. But the key thing now is that we have a template which we can use and pass around and store in source control. And that's great. So certainly from a pros point of view, we can now automate that deployment. We're no longer clicking in a portal. We're not having to have somebody click through menus to create things. Scripts are usually idempotent. So in ARM, you can run the same script several times and it won't generate multiple resources unless you're specifically doing some changes to it. They're declarative. That's the key thing. One of the key things here is we are defining what we want the state to be, and we're letting ARM figure out how to do it. ARM is going to figure out how to provision the resources. We're not telling it imperatively how to do it. And this way we can now provision multiple resources very easily. We can take the same ARM template for the storage accounts and we can create multiple storage accounts if we want. And in most cases, the dependency graph is resolved for us. ARM will figure out that we're using the storage account in something else. Let's say, for example, in a web application, we will then ensure that the storage account is provisioned first before the web application is provisioned. So one of the challenges, well, what we've seen with the ARM example is it was very verbose. We had full line, full page of essentially JSON, a JSON-esque syntax. We need to learn the domain-specific language. So we have those concat functions, we have those variable functions. Those are specific to ARM. And if we're using ARM, we have to understand them and learn them. They're also specific to Azure in this example. And also the ARM engine is closed source. We don't know how it works. Because of some of these challenges, another tool that's gained a lot of prominence is Terraform. So Terraform is a tool from HashiCorp. They use their own version of a markup language called HCL. And one of the key things with Terraform is it's multi-cloud, multi-platform. So you can use Terraform to provision resources on many, many clouds and many other service providers as well. It's an open source product and it's ready and go. So let's take a look at a similar example in Terraform. So here's the storage account in Terraform. As you can see, the first thing that strikes you, hopefully you can see, is it's a lot clearer. There's just nowhere near the same amount of text on the screen. So it's a fair bit easier to read. So take a look at a couple of specifics here. So here we are taking the resource group name and the location by essentially referencing the prior resource and dotting into it. So we're taking that example resource here and we're getting the name and the location. Again, this looks a little bit more understandable than the weird syntax we've seen with the ARM templates. So that's great. There are some challenges with Terraform as well. Terraform uses a language that's specific to Terraform. So there's, again, a domain-specific language you have to learn. Support in Terraform will always lag behind the cloud provider. So the way Terraform works is that cloud provider will expose a new API for provisioning some new resource they've just released. And then the Terraform community or the Terraform HashiCorp themselves will develop, essentially expose that as a feature within Terraform. That invariably takes some time to do that. And then finally, state management. I mean, I don't think this is as much of an issue as it is. It used to be, but state management could be a bit of a challenge, particularly around secrets. So far, we've seen really trivial examples of storage account, and Terraform definitely looks a lot better than ARM in that example. Sometimes you have more complex deployment scenarios. You may need conditional logic. You may want to deploy certain resources based on some condition. You may want to deploy multiple instances of certain resources, or you may want to provision or invoke third-party code. So let's take a look at some of these using both ARM and Terraform. So this is an ARM example for conditional logic. So what we have here is we've specified some parameters and we've given it essentially an array of allowed values, yes and no. And then we're using this to say, well, we want to provision this resource if we're in production. So what we're seeing now is we're seeing this equals function. We're reading the parameter for production, which is here, and then we're checking if the value is yes. And if that is, the condition is met, and we will deploy the resource. But again, what call out is this syntax is not necessarily immediately obvious. You would need to look this up if you were working with ARM for the first time, or if you've not worked with ARM for a while. Let's take a look at this example using Terraform. So in Terraform, they're using account properties. So they're doing a ternary expression and basically saying is prod. If it's true, then the count is 1. So we provision 1 instance. Otherwise, we provision 0 instances. I should say there may be other ways of doing this. This is just the examples that I've picked, that I've used. So look at loops. So this is an example of looping within ARM. So we've got an array. We've got an array defined with production and development, and now we want to essentially provision 2 resources using the name. So for the name, we do this starting to look very complicated now. We're doing a concat, we're taking a string, we're taking that array, value, and we're looking at the current index, so the current position in the array. And then we're using the copy function here to say we want to provision n number of instances of this based on the length of that array. So this is starting to look a little bit more complicated than I would like for these kinds of things. So similarly in Terraform, we have a similar situation. We have a list of 3 values, and we are now specifying the length of that array as being the number of instances we want. And then we're using the indexer for the environments to figure out the current value. So the name will be the current position we're in the index. So this looks a little bit more readable, but again, it's not the most intuitive. These are reasonably straightforward examples, but the syntax is starting to look slightly, less obvious. It's not as interesting. So when we come back to this definition, the word that really strikes me is code. When I think of code, I think of software, but what we're really seeing is markup languages with code kind of constructs shoehorned into them to solve a problem. And this is where the term kind of infrastructure as code is kind of maybe being replaced with infrastructure as software. Certainly the folks at Pulumi are, I think they coined this term. So what is Pulumi? Pulumi is an open source tool for provisioning cloud resources, but actually not just only cloud, but let's just say for cloud for now. And this key thing is it allows you to use modern programming languages to do this, rather than essentially YAML or JSON that's been glorified with some very special syntax. It supports many platforms, and it's declarative. So when we take a look in a second, you may think that the code is imperative, but actually it's a declarative approach. It still is. It's an open source product as well. There is a console that essentially they have a platform as a service offering, which is not open source, but everything else is open source. Pulumi supports a number of programming languages, specifically Node, Python, .NET Core, and Go. Pulumi is a very pluggable infrastructure, pluggable approach. So actually you can write your own language service if you want and support your own language. I'm sure that's something not particularly trivial to do. In terms of supported platforms, this list may be slightly out of date now, but as you can see, they support a good number of providers. So the core providers are the main cloud providers and also Kubernetes. And then they also support other infrastructure providers. So we can see things like Docker and Kafka, some database providers, and even network providers, things like Cloudflare. So we're seeing a diverse range of platforms here, which is quite interesting. How do we get started with Pulumi? Well, Pulumi uses a command line tool as the primary kind of tool to create and develop Pulumi projects. So what I can do is do Pulumi new Azure C#, and that will provision a new Azure project for C# using C#, sorry. So it just gives me a couple of steps I need to follow. So just give it a name. I'm creating a stack. A stack is essentially a configuration. So for example, your dev environment may be a stack, and you may have a production environment as another stack. Once we're ready to go, what Pulumi has done is essentially created a C# project for me with some Bootstrap code in it. So let's take a look at that code. So pop open in Visual Studio Code. And what we can see here is a reasonably straightforward project. Again, this sample is slightly old, so the syntax looks like the project looks slightly different now, but everything I'm saying is still relevant. So let's take a look at the program, the CS proj. So first thing to see is it's a .NET console. It's just a .NET console, .NET Core 3, and we can see we've got this Pulumi.Azure reference. That's the NuGet package that's going to provide a lot of the resources that we're going to use in a second. So let's take a look at the program. This is the whole program.cs. And what we can look at here is we are essentially creating a resource group by doing var resource group equals new resource group. This is C# code. We're newing up a resource group. We're passing in a name. Then we're creating a storage account. And here what we can see is that we need the name of the resource group within the storage account. So we can just do bog standard C# and we can just reference that variable we defined earlier and take the name property out of that. The rest of the properties are standard. We're doing a locally redundant storage and standard tier. Well, once we've got that, how do we provision it? How do we provision the storage account? We come back to the command line And what we can do is do Pulumi up. And what that will do is it'll compile the code. Once the code is compiled, it's going to essentially look at what we've said and it's going to tell me what it's going to do. So it's telling me that I'm going to create 3 resources and it says, do I want to go ahead? So when I say yes, it does compile again. I think it's just to make sure that you haven't changed anything in the meantime. And now what it's going to do is going to go ahead and start provisioning those resources. So what we'll see is the creating progress bar. And then within a few seconds with this simple example, what we'll have is we will have our storage account, resource group and storage account provisioned. So we'll see that. I'm letting this run in real time because I just wanted you to see how it's actually happening without any smoke and mirrors. And what we can see that it's provisioned that it took 33 seconds and it's given me back the connection string to that storage account. Don't worry about the fact that the secrets are visible. This storage account is long gone. So, okay, great. So I've just created some storage accounts, a storage account and a resource group in Azure. But what if I want to change something? So what I can do is, let's say I come back in and I want to make a change here. So I've got, I want to add some tags. Tags are something we often forget to put onto our resources. So what I can do now is I can do tags equals, and I just pass in basically an array of strings. Now, if I come back to the terminal, I can run Pulumi up again. And this time what will happen is Pulumi will look at the current state of my infrastructure versus what I've now created in my application, and it will work out the difference. So it will say, here's the difference. And what it tells me is it's going to update one resource and it's going to leave 2 things as they are. Do I want to go ahead? So when I say, if I look at the details, I can see specifically what it's going to do. So it tells me it's going to add these tags in there. And then I can just go ahead and say yes. And then I'm going to let it run. And again, it's just running live and it will, well, it's recorded, but it's running in real time. And it will just say, I'm going to update the storage accounts. So it's not doing anything else. It's not re-provisioning the storage account. It's not creating another resource group. And there we are. In 11 seconds, it's done. Okay, so now we've created a resource group and we've changed it. We've created storage account and we've changed it. You haven't seen anything yet, so you're taking my word for it, the fact that this does exist. So let's take a look at the portal. So here we are in the portal, and first thing you'll notice is if I kind of expand a bit, we can see the resource group, and then we've got this weird string at the end. What's going on here? Well, by default, Pulumi will append essentially a bit of unique string to the end of the name of the resource group you've given it. And essentially what that does is it minimizes the risk of any conflicts. Now you can force Pulumi not to do that, but that's not recommended because you're likely to get conflicts. I know certain organizations have a bit of a thing about having a naming standards. You can still follow a naming standards with a prefix within limitations on certain resources, but you can still have a prefix on resources and then just ignore the bit after the random numbers afterwards. So what if I'm finished with this? What if I want to get rid of it? What I can do is just do Pulumi destroy. And what that will do is we'll take a look at what it's got and it will just tell me it's going to delete everything. So if I hit yes on that, then within a few seconds, Pulumi is just going to have destroyed that storage account. So what's really powerful here is that I can spin up my infrastructure very quickly. I can, use it for something and then I can just delete it again without having to go through all of that portal steps or even the, what I think a lot more complicated templates. Very briefly, the way Pulumi works is it has a language host which you write your language in, and essentially that gets translated into a graph, an object graph that gets sent to the Pulumi CLI and the Pulumi engine. And the Pulumi engine essentially interacts with the cloud providers. So they will invoke the cloud providers APIs. So in the case of Azure, they are invoking the Azure ARM API to provision the resources. So all of the cloud providers expose this. And the key thing here is that any service which exposes an API can therefore be controlled through Pulumi, because as long as the API is there, so in the example in this image is Kubernetes. Kubernetes has a very strong and actually very good API, and therefore Pulumi can be used to provision Kubernetes resources as well. Pulumi also has this console. I mentioned this console. So Pulumi has this console that lets you essentially see what's going on with your different projects and stacks. So we can see here, this is my kind of demo, and specifically it's a dev stack. And what I can do is I can take a look at the configuration. I won't pop that open. I can look at the activities. So I can see what's been going on with this particular stack. So you can see that I did an update and it tells me what I updated. And I can even look at the diffs, so I can get real detail about what was going on here. And then I can step through all the changes that were made to the infrastructure. So we can see now, then I added, made some changes here, and then eventually I deleted it. So you can see the 3 steps that were taken. So it's a nice way of being able to visualize what's going on. So the Pulumi console is part of the commercial offering, although there is a community version which is free for a single user as well. Unlimited stacks as well. So you can do as many of these as you want, and it's free. So far we've seen kind of essentially replicating the storage account examples, but now using C# code, and that's pretty cool. But there's another thing you can do that could be quite powerful. So what if you need to invoke third-party APIs as part of your provisioning? So if you're using ARM templates or Terraform, you often need to drop out into some kind of script. You need to drop into maybe some PowerShell script or a bash script of some kind. And one of the challenges with this is it's not easy to test that. You often rely on third-party tools being available on the machine you're running on. You need to ensure that bash is there or PowerShell is there. Now, I appreciate that's not necessarily problematic nowadays, but if you're using some kind of custom CLI, for example, that could be a problem. The other key bit here is there's yet another language you need to be familiar with or comfortable with. So, you know, you're doing ARM templates, and now you maybe also need to learn bash or PowerShell as well. So I want to talk through an example which actually is no longer problematic, but this was an example that really opened my eyes to the power of Pulumi in particular in this scenario. So we wanted to provision some static storage websites. So this is storage accounts that can host websites. At the time, that feature couldn't be enabled through the Azure ARM API. I can't remember if it's now enabled. Similarly, this was something that you couldn't do in Terraform or Pulumi. Pulumi didn't have this option available and needed a Terraform. So the only way you could really do it was to invoke an Azure CLI script. So when I was looking at this problem and I wondered, well, I'm in .NET, I'm writing C# code. Can I not just use the Azure Storage SDK to enable the storage account? So the short answer is yes. So as I said, both of these things are now fixed. They are natively supported in Terraform and Pulumi, but I think the concept, the principle is still relevant, which is why I wanted to mention it. So let's take a look at that example. So here's that storage account again. A little bit more things have been specified on here, but the key bit is what we do is once we've created the storage account, what we're doing is we're checking from Pulumi's point of view, are we doing a preview or are we actually running this for real? Because if we're doing a preview, we don't really want to bother invoking this code. So that's what this is dry run is doing. We're grabbing the storage account that we provision, we're grabbing its primary connection string, and we are passing it into this function, this enable static sites function. So let's take a look at that function. And that function is now using the Azure Storage SDK, and it's connecting to the storage account using the connection string, and it's enabling the static sites property. So again, this is all just C# code, so code that you as a developer, be very familiar with. And then once that's done, we can then go ahead and upload some files to that storage account, and then we're done. And when we create this, what we can see is we're still running Pulumi code. We're still doing Pulumi up. We're not having to do anything special here. We're not having to run a separate tool or anything else. We're still doing Pulumi up. Pulumi is going to run its own code, and then it's going to execute my code as well as part of that. And the storage account's created, and the files uploaded to it. So what about a slightly more complicated example? So for example, here we've got a storage account. We've got an application gateway, and we've got some web applications, and we've got a database. Anyone who's provisioned application gateway will know that they can be quite challenging. The ARM templates for them can be very big. We have a scenario where one of my clients, a scenario where we were potentially deploying a single region, and sometimes we were needing to deploy to multiple regions, or certainly to 2 regions. So in the multiple region example, what we needed to do was additionally, we wanted to create 2 instances of the application in 2 different regions. We wanted to set up geo-replication with the database. We wanted to set up failover on the database. We wanted to configure traffic manager to route the traffic. Now, if you look at this example and how you might create this in ARM or anything else, this is very challenging to have something coherent in ARM to do this, just from the verbose nature of it. In particular, what we're doing is the number of web apps could be different. There could be n number of web apps depending on a particular configuration. So in order to provision this, what we need to do is essentially provision 2 sets of the resources. We need to configure the gateways with the addresses of the apps, the endpoints. We need to configure a SQL failover group, and we need to configure a traffic manager to do this. So let's take a look at an example of the code to do this. Now, I will warn you, the code is a little bit gnarly because I did prefix it by saying I'm not done a lot of development recently. But I think rather than looking specifically too much at the code, the bit I want you to take away from it is, for example, here we are provisioning some static sites. We're just doing a for each loop. We're just doing for each. Let me show you the config, actually, that'll make more sense. So in the configuration, I have this array of static sites. So I've only defined 1 at the moment, but I can put another one if I wanted to, just in there as another site. So what I've got is the name of the site and the host header I want to route the traffic from. So I'm just going to put that back in case I break something. So I'm just doing a for each block. There's none of that syntax with the copy index and copy n number of times. It's just a copy block. Similarly, with I have an option to say if I want to do a multi-region deployment or not, just a Boolean flag. And in my code, I just have a if config is multi-region, goes ahead and does that. For example, here we're creating a network and we're passing in the objects we're creating into other functions. So we're going to create a database server, and then we're going to configure a failover server. So if I go to this function here, we're going to take the primary SQL database server, and we're going to configure a failover. We're taking the IDs. This is all code as a developer is reasonably understandable. So let's take a quick look at, so what I've done is I've gone ahead and provisioned this just before we started talking, because it takes, well, you can see how long it takes 7 minutes and 36 seconds to provision. But you can see that it's provisioned a bunch of these resources. So we can see EU West and EU North are the 2 regions I've used. So we've got here, we've got App Service Plan, we've got SQL, we've got App Insights, got virtual networks, we've got Traffic Manager profiles, app services, got a failover group. So let me show you that in the portal. So let me get the portal over, and let's just do that. And just refresh that. So we should see that here is one of the regions, and I can see, sorry, it's a bit, can I just make it a bit smaller because it's, whoops, not that. Control Shift, zoom out. Whoops, the wrong way. There we are. Make that a bit more readable. Here we are. We have the resources. We have the app gateway. If I click on the app gateway, anyone who's tried provision app gateways knows this can be quite painful. I have some backend pools. There's my 2 backend pools. That points to the, so this is a static site, points to the connection string of the storage account, the HTML, the web endpoint rather. And then we have the API as well. I should be able to go to see where my traffic manager is. Can't see my traffic manager. I should be able to go to admin portal demo at cloud.com, and we can see that's working, that's loaded. So one thing I haven't done in this example, but is I'm using Cloudflare for my DNS, and I've pre-configured the DNS, but I could have used Pulumi, as I've shown you. DNS was one of the options Pulumi had. I could have gone ahead and provisioned, got Pulumi to actually update my DNS records for me as well, so done the full stack. But in this demo, I just decided to keep it simple. The key thing is I have all of those resources, and it took 7 minutes to provision. If you try to do that in the portal, I couldn't even tell you how long that would take. Now I've, maybe I finished with the demo. What I can just do now is do Pulumi. I've aliased Pulumi on this machine, so I can just press P, but I'll just type it out. Pulumi destroy. Oops, I can't type. Let's do that again. Me destroy, and I'm going to be really brave. I'm just going to say, don't even bother warning me. I'm just going to go ahead and destroy. So what Pulumi will do now is it will go ahead and start. It tells me what it's going to do, and it's going to start deleting those resources. So imagine you're doing a pull request for a reasonably big feature. You can have Pulumi provision all of your infrastructure. You can then test it, and then you can destroy the environment when you're finished with it. It's really quite powerful. So why did I kind of land on Pulumi? Why did I find Pulumi being really interesting? Well, it was challenges working with small teams. In particular, these small teams had developers who were doing, maybe full stack, maybe they were back end or front end, but they didn't have anybody who was dedicated to managing the cloud resources. I came in to help them with it, but I didn't want to be I didn't want them to be dependent on me. As much as that's great for my business, it's not the way I like to operate. I want them to be independent. And when I tried to create the ARM template for the gateway was when I really hit these challenges. I couldn't, in all faith, leave them with the ARM template, knowing that they don't work with ARM day in, day out, and maintaining it is just going to be too complicated for them. Similarly, I don't use ARM day in, day out, and actually I found when I went back to them a month later, I was struggling to get my head around the ARM template. So if you're a dedicated team, doesn't have a dedicated resource looking after the cloud infrastructure, then you may be developers who are familiar with Python, familiar with .NET. So it makes a lot of sense that why are we having to learn a different language to provision our resources than the language we are using day in, day out. We didn't have to have complex templates or even duplicated code. Sometimes you can't do the things you need to do in software in those ARM templates. You have to copy blocks of code. And often you need to coordinate several steps, and this is all something that you can do with Pulumi. So as I said, the key bit here is the teams I work with, they don't need to learn another language, and that's great. So that's really where Pulumi kind of helps. So likelihood is that .NET and other languages is something you're going to understand more. And then also the tools you're using. We're using .NET CLI, and we're using Visual Studio Code, and we're using GitHub to commit things. And then also the Pulumi console is available for us to see. Everyone in the team can see what's going on. They can look at the Pulumi console and see the details. Obviously, depending on the size of your team, you may need to pay for that, but that's a small price to pay, in my opinion. The other thing you can do with Pulumi is you can create a bunch of reusable components. So you can create a stack of resources which get deployed together, and then you can package some of those up into a NuGet package. And you can reuse that in your organization. And then you can compose these packages and these deployments together into making reusable components. So you may have a default way that you want your SQL service to be configured, and you can have that as a pre-configured package, and then other people can use that package. Well, I've just seen my animation's gone a bit wrong, but won't worry about that. So what about working with existing resources? Well, there's a flexible way of doing this. So what Pulumi can do is it can work alongside existing resources, and it does nothing to them. It just leaves them alone. So when you do Pulumi delete, it wouldn't delete those resources. It will leave them there. You can adopt existing resources. So this is essentially where you tell Pulumi that here's the ID of some resources that are already there, and it will basically bring them into the Pulumi kind of state management, if you like, but there's no code generated for you. And of course, you can just rewrite your ARM templates in Pulumi if you want, and then have everything managed by Pulumi. New is an option to import your resources into Pulumi. So using the Pulumi tool, you can actually import existing resources. And what's really cool is Pulumi will generate the code for you, which is super awesome. So now you're having existing resources brought into the kind of Pulumi lifecycle, if you like, and that's really quite powerful. There's also another tool, a bit of an older tool, which let you kind of convert Terraform to Pulumi code as well. So what are the pros with Pulumi? As I said, you're using languages which your team's already familiar with. To me, it kind of strikes me as really weird that why we have to learn a totally different language to deploy something that we've written it in a language that we're very comfortable with. With the power of the modern languages, we can use third-party SDKs to achieve almost anything we want within the code. We don't have to drop into scripting. It's actually really easy to get started. And it's free to use and it's open source. Unless you want to use that console, you can continue using Pulumi as much as you want without that console, and there's no issues there. So is everything kind of unicorns and rainbows when it comes to Pulumi? Well, there are some challenges. So there are fewer supported platforms than Terraform, but again, the model is very open. So if there is a platform that you want to support, you can go ahead and write the provider for that if you want. So there's a lag between the way Pulumi works and the feature release in a cloud provider, understandably so. But actually, this is changing. There's a new Azure provider called the Next Gen provider, which is being generated from the Azure APIs every night. So there will be much less of a lag. When the Azure API changes, they'll be reflected in the provider almost immediately. By default, the Azure provider that Pulumi uses is actually using Terraform behind the scenes. So Terraform is an open source project, and therefore Pulumi is currently using Terraform to do a lot of its automation of Azure. This is a dependency on a competitor product, which is a bit weird. But again, this is where that next gen provider comes in. So the next gen provider is not using the Terraform provider behind the scenes. So it removes that dependency on a competitor product, but also it reduces that lag between a feature release and it being available in Pulumi. But that is a preview provider at the moment. Continuing the kind of challenges, well, there's still a lot to learn. So one of the key things is, right, we're using C# syntax now, and that's great, but you still need to know what the variables, what the options you have available, and what you should pick. Should you use a locally redundant storage or a zone redundant storage or a geo-replicated read access storage? You still need to understand that, and you still need to kind of discover that. Some errors are not always apparent when you run Pulumi up. Some errors are not always apparent until you try and provision the resource, then you may get an error. A lot of that's not really Pulumi's fault. It's because there are issues with the API. Maybe certain things are not documented clearly enough. A common one that can trip you up sometimes is things like storage accounts. They are very restrictive in what names you can use for them. Pulumi tries to give you that when you do a preview. It tries to highlight a lot of these beforehand, but some can only really come up when you are deploying. And it can get yourself in a bit of a state. So if you are provisioning resources and you suddenly decide to cancel, then there can be a bit of a synchronization issue, because Pulumi is essentially telling the cloud provider to provision the resources, then it's waiting for it to finish. And if you suddenly tell Pulumi to cancel, then it doesn't necessarily know what's happened and what's going on, and it can be a bit confused. There are ways of fixing that by essentially editing the state that Pulumi thinks the resource is in, but just want to mention it. And it does tell you not to do it, so my fault. So the alternatives, what about these? So we have SDKs, all the cloud providers have an SDK. So why don't we use those? Most of these SDKs are essentially wrappers around the REST API that the cloud provider has. So the challenge with that is they're often imperative APIs. They're not always idempotent. And the key thing with them is there's very difficult to reason between the current state of your infrastructure and the new state that you're trying to provision. So they're very much about creating a resource and then you're done with it, rather than tracking how that resource is changing over time. Similarly, there are transpilers. So essentially these take often a general purpose language and they convert it into a template. So AWS has a CDK, a cloud development kit, and essentially this takes .NET code and I think other languages as well, and it creates CloudFormation templates. And Farmer is an F# project, a very cool F# project that does something very similar and generates ARM templates. So these are kind of really interesting projects, but they have a lot of the same limitations when it comes to they're specific to a cloud provider, and ultimately they are just generating templates behind the scenes. If you're familiar with Azure, you may have heard of a project called Bicep. So Bicep is a project from Microsoft where essentially it's a domain-specific language, a DSL, for creating ARM templates. So this allows you to build ARM templates quicker and easier. Fundamentally, this is very, very similar to Terraform. It's another domain-specific language that you need to learn, and it's Azure specific. So it still has the same limitations around needing to learn the domain-specific language and it being Azure specific. So the way I kind of approach this, way I think about this, when we look at the journey, if you like, or the evolution of provisioning in the cloud, when you start off, you're kind of working with portals and that's great. You don't really know any better at the time. Then you kind of evolve a little bit and you start using these templates, and that's great because now you can do these things automated, and that's fantastic. As you evolve a little bit more, you switch to Terraform because Terraform's a bit more, less verbose and a bit easier to use. And then I think, and it's a bit tongue in cheek because I love the folks at Terraform, HashiCorp, but Pulumi to me feels like the evolution, the next step in that evolution. Now we are using languages we're familiar with and comfortable with. So if you want to learn more, there's a huge repo of examples in every cloud provider, pretty much every language, very common examples there. That's a great place to go. There's a Slack channel for Pulumi, and I've got to say the Pulumi folks are just amazing. They will respond to your questions with just superhuman response times. It's incredible. Like I post an issue and on GitHub, and then within hours they've already told me I was probably doing something. I was usually doing something wrong. Similarly with the Slack channel, they're just open, welcoming. So a huge shout out to the Pulumi folks. They've been awesome on helping this. And my blog is there. I promised I was going to write more about Pulumi. I don't think I really got around to doing that, but I will. So I think with that, I'll wrap up my talk. I'll leave the links there, and I think we can switch to questions. Apologies, I didn't have the right Q&A screen open during the talk, so I missed the questions as we went along. But I should be able to do that now. So is there a way to provide values for which Azure subscription? Yes, absolutely. So let's pop back to the code here. So in this config, you notice that I've got a SSL certificate password. Oh my God, I've just put, and this file is in source control. So what Pulumi actually does is it encrypts any secrets you're using to the stack you're using. And you can configure the way the encryption works as well. You can use your own encryption if you want, not your own coded one, hopefully, but your own provider. So it's safe to commit. So you can include the Azure subscription details in there. The other thing it does, and that's what I was using, is I'm signed into the Azure CLI. So it's picking up my Azure CLI credentials as it's running at the time. So Gopal had this also the same question. And then presumably there's a marketplace tasks on Azure DevOps integration with CI/CD. Yes, I'm pretty sure there is GitHub Actions and there are marketplace options, but otherwise you can just use the Pulumi CLI. So that's it. Yeah, the way this is should work is that once you provision the resources, then your source control, that code is in your source control. And if you want to make a change to your infrastructure, you would make it in the Pulumi code. You would then do a pull request, and then when that pull request is merged, then it should apply that change to your infrastructure, to your environment. So that's that. I think there's no more questions.
Oh, there's one more.
Oh, one more just
come in.
Yeah.
Is it fairly straightforward to do multi-cloud deployments with Pulumi? And that's from Anonymous. Oh, and another one's just come in.
Yeah, so yes, I guess the short answer is yes. I mean, we won't get into the multi-cloud debate, but yeah, essentially you can use different providers, and as long as there's a provider available for your cloud, you can do that. I've never tried that actually, but it could be quite interesting because you could probably even share values, outputs from one cloud provider and pass it as inputs to the other cloud provider. So you might be, maybe you're setting up some kind of gateway or some kind of a proxy and you want to route traffic to the other cloud provider, you could potentially do that as well. So that's, yeah, it's pretty cool. Thank you, Anonymous, and thank you, Jonathan. I think is any more questions just off the screen? Well, we've got about 10 minutes. I'm happy to stick around if people got questions, or if people have dropped off, then I guess feel free to reach out to me on so Twitter. I'm very active. My DM's always open as well. So if you've got any questions, feel free. Otherwise, yeah, thank you very much, and enjoy the rest of your DDD conference.